Alright, U.S. Army Engineering Center and School Construction Equipment Brake Systems. Lesson 1, Brake System Principal Critical Task 09162B 1005, 09162B 3054. Introduction, braking action, you with the control force will flow down the top of the object, the whole of the object stationary position. Braking action, the result of the friction called the two surfaces rubbing together. Example of the friction from the force of the driver's shot of your hand as you apply the pressure slides it across the top of the desk. That means the forcing a surface with the object is not stationary and not moving. Stationary move against the object surface. The resistance to moving the rubbing action between the two surfaces of the object will slow down the moving surface of the braking system. One surface rotating, one surface non-rotating. Brake 1-1, brake history. And brakes on the earlier motor vehicles were nothing of the modified with wagon brakes on the horse-drawn wagons. These rear hand-operated mechanical lever type the forces a piece of the wood against one or more wheels, causing friction drag on the wheels on which shown figure 1-1, page 1-2. This action will result in the friction between the wheel and the ground that tries to prevent the wheel and sliding or skidding. Figure 1-1, developing the friction and heat, show the friction and the heat. A1-2, external contracting, internal expanding brand with many different brake systems. All systems require the use of rotating, non-rotating. You the unit with the brake, show the force. Together produce friction required for the braking action. Rotating unit with any of the vehicle brakes consist of the drum that is secured but driven by the wheel. The non-rotating consists of the brake shoes. Linkage required to apply the brake shoes to the drum. Brakes may be external contacting, internal expanding. Figure 1-2, 1-3, depending on how stationary surface is force against the rotating surface. External contracting type. Brake lining, forcing on all levers of the brake band, brake lever and fulcrum in a drum. The internal expanding shows the anchor pins to the drum, the brake lining, the brake shoe, and the command cam to expand the brake shoe. 1-3, rotating, non-rotating brake joint. You with the brake drum down directly on the wheel to provide with the rotating surface of the brake shoe. The man with the non-rotating surface of the primary function of the brake shoe. Some lead the force of the brake shoe again with the rotating drum to provide braking action. Self-energizing action. Making the drum and some will just call the self-energizing action. Self-energizing is produced with the brake shoes. The gauge with the rotating drum with the brake action. Actuating mechanism for the brake shoes outward shown in figure A with the figure 1-4, page 1-4. The top of the brake shoes stand the stick of the wedge with the rotating brake that rotates with it. With the effect of the brake shoes directly to produce the amount of effort required to achieve the give of the amount of the retardation that the brake shoes were linked together as shown in figure B with the figure 1-4 with the application shoes were produced in self-energizing servo effect. The servo effect resolved with the primary shoe with the brake shoe facing towards the front of the vehicle, attempting to rotate the brake drum due to the both shoes being linked together, rotating the force of the primary shoe with applied with the secondary shoe in the forward position anchor point for both brake shoes at the heel of the secondary brake shoe. As the vehicle changes direction, the toe of the primary brake shoe becomes the anchor point in the direction of self-energizing servo action shown in figure C, figure 1C. 4. Alright, shows the cam applying force of the drum rotation shoe, anchor pin, and drum. Air brake shoe self-energizing action. B, the car moving forward, held adjusting screw, drum rotation, secondary heel, anchor pin, applying force. Car moving rearward, applying adjusting screw toe, adjusting screw toe and toe. Alright, your brake drum assembly configuration, the most popular configuration of the brake drum assembly that discussed below. The single anchor self-energizing servo action with configuration and A1 for the page 5 with the 1-6 for the both brake shoes, self-energizing forward with the reverse direction. The brake shoe with the self-centering provides servo action during the brake application. The system has an anchor pin with rigidly mounted with the braking plate with is non-adjustable for the forward reverse brake torques that transmitted the braking plate through the anchor pin when the brake some of the dual pistons configuration with the 2 with the single anchor self-centering configuration with the B1 for the 1-5 with only the brake shoe with the self-energizing forward direction, therefore the provide with the majority of the brake shoe. The system self-centering in the lower shoe anchor does not fix to the point of the brake shoe relation with the brake of the drum. The brake shoes are allowed to move up and down as needed. The system has one brake cylinder. Double anchored single cylinder with the configuration C with the figure 1-5 with each of the brake shoe with its anchor at the bottom of the rotating eccentric shape with the anchor pin only with the primary shoe self-energized. The system does not develop the servo action spring setups used at the mouth of the shoe to hold the shoes again for the brake plate, but the system has one real brake cylinder, double anchor, and a double cylinder with the configuration D with figure 1-5 with the brake shoes are provided with the anchor. Each heel with the anchor is eccentric shape with allowed with adjustment centering, and each shoe has single pistons of cylinder mounted with the toe of the shoe with the brake. Which allow the brake shoes to self-energize the forward direction only. 1-4, the brake drum constructed for the brake drums are made pressed steel cast iron combination of the two metals and aluminum. The cast iron brake drums, the brake drums dissipate with the generated friction, but the faster with the steel drums heavier, the higher the efficiency with the friction on a particular brake. However, the cast iron drums are sufficient strength and are heavier than steel drums to provide lightweight with the brake drum. The sufficient strength with the centrifuge, the brake drum figure 1-6, page 1-6, with the made of steel with the cast iron liner with the braking surface of the solid cast iron brake shown with some the same total thickness of the configuration drum would be to be weak, while one of its position strength would be too heavy with the average passenger car. Breaker 150 of the brake drum assembly configuration: A, single anchor self-energizing tape from the 12 o'clock anchor retarding spring with secondary hold down star wheel, adjuster spring, primary shoe wheel, cylinder drum, and show the rotation angle. B, single anchor self-centering starts at reverse shoe in short lining eccentric cam, self-centering anchor, and brake forward long lining eccentric cars. Eccentric cam counterclockwise rotation. C, double anchor single cylinder primary shoes, forward shoe, single secondary shoe, reverse shoe guide, and spring caps, counterclockwise rotation. Double anchor double cylinder anchor pins. 1.6 cooling rib steel with a cast iron liner, aluminum steel, aluminum cooling cast iron liner with a steel cast iron braking surface. Aluminum brake drum. The brake drum with the construction similar to the centrifuge with the aluminum cast iron line with the braking surface to reduce the weight with the design allow the heat to be transferred to the surrounding atmosphere more rapidly. Cooling fins and ribs are also added to most brake drums that allow heat with the transfer to atmosphere more rapidly, thereby keeping the brake drum cooler and helping minimize the brake fade. Brake drums with good braking with the action of the brake drum shift perfectly around. They have uniform surface of the brake drum that become with the round with the form of the press serve with the brake shoe for the heat of the develop the application for the brake drum surface becomes scored with the warm with the braking action. The surface is scored with the brake of the drum is out of the round building necessary for the machine of the brake drum until the smooth and true it again. 1.5 brake shoes and lining construct for the brake shoe lining with the figure 1 side of the work with it together with the brake shoes with the support with the strength with the move with the brake line with the brake shoe is made with the multiple iron cast iron forged steel press steel and core cast iron aluminum. Press steel is commonly used together with the cheap to produce the large quantity of the steel brake shoe with expand with the same rate of the brake drum when heat jammed with the brake application, thereby maintaining the clearance between the brake drum and the brake shoe under most conditions. Brake shoe and brake lining. Brake lining, brake shoes. Molded brake lining and then woven broken lining. Woven brake lining. Brake lining of the brake lining is mounted with the base of the brake shoe and the contact with the inner surface of the brake drum with the brake rivet that shows on the other type of the brake shows down screw with the brake drum. The excess with the lining is worn plastic placement and aluminum rivets are not used because they are corroded due to the moisture brake limit and may be bound with the brake shoe with a special cement and it's not always necessary to fasten the lining with the shoe. Some brake assemblies of the lining is not fast with the brake shoe with the brake drum but floats on them and is held with the lining of the retainer on one side with the brake shoe on the other side. Brake lining type. The variation of the brake design operation may be necessary for the different type of the brake line shown figure 1 side of the page. 1 side of the braking lines come in the mold of the woven type of the mold of the lines made with the dense compact asbestos fibers. The lining sometimes impregnated with the fine copper wire that may be cut into the blocks of 2 different sides of the which will match the corresponding brake shoe. The frictional qualities are low because the smooth surface that dissipates with the heat rapidly wear along with the woven brake lining. The woven lining is made of the asbestos and fiber, the copper and bronze wire that has been given with the lining with treated with the compounds and with the lessening and effect of the water and oil. The lining compressed with the heat and treated before it's installed. The main advantage of the woven lining is high friction qualities. Woven lining does not dissipate in heat rapidly as molded brake lining. 1/6 disc brake assembly. The system consists of the disc brake assembly floating fixed in the caliper's pit and multi-piston design. The disc brake operation, disc brake assembly figure 1/9 with the brake drum assembly with operated pressurized hydraulic fluid with the fluids rotate with the calipers through the steel line flexible high pressure hose developed and pressed with the master. Cylinder 1 brake pedal is depressed with the fluid ends with the caliper begin with the force for the piston outward move with the force for the brake pads again for the move with the rotor. 1 with the point of the reach of the braking action begin with the greater fluid pressure is reduced exerted to the piston from the master cylinder with the tighter of the brake pads with the force against the rotor. Increase the pressure will increase the brake effect for the pedal with the release pressure with the diminishes the force of the brake pedals is reduced that allows the rotor to move more easily. Some of the calipers also brake pads rub lightly against the rotors at all times in the release position. Another design use the roller action piston seal to maintain a clearance of about 5,000th of an inch when the brakes are released. Disc brakes versus brake drum assembly. Both disc brakes for the brake drum assembly used with the modern vehicles of the well-designed systems or each of the system exhibits a certain inherent advantage and disadvantage. The most important points of the interest discussed below on the major factors that may be discussed for the automatic brakes as well as the other brakes in the system that may be able to ability to dissipate heat, but further discussed previously by the byproduct of the friction as heat. Because of most of the brake systems, due to the concept of developing and braking high desirable brake system to dissipate with the heat rapidly and efficiently possible. The disc brake assembly, because it opens the design has the ability to dissipate heat rather than the brake drum assembly. The feature becomes the disc brake assembly less prone to the brake fade due to the buildup of excessive heat. The disc brake assembly may be the additional heat transfer the quality to do with the ventilation rotor with the type of the rotor. Figure 1.8, page 419, has a built passage between friction sources to aid the cooling. While the brake drum assembly requires the initial shoot of the drum, the clearance for the adjusting of the periodic check for the disc brake assembly, self-adjusting maintained for the proper line adjustment all time. The disc brake assembly will automatically compensate for the lining wherever allowing the piston in the collar to move outward, thereby taking up the clearance between the pad and the rotor of the disc system. And the simply comparison of the drum system, due to its design lack of the movement of the spring with the disc brake with the assembly, is likely to malfunction with the brake drum assembly. Overhauling the disc brake assembly is faster because of the simple design, also safer due to the fact that the disc brake assembly is open into the obsessive depth of the links, less apt to be caught in the brake assembly. Like the brake drum, the rotors must be machine accessible scoring. The present rotors also same with the minimum thickness dimension, with the should be not exceeded. The brake drum, the assembly requires the drum to be removed with the lining inspection. Some of the wrist pads have the multiple built-in lining with wear indicator to produce the audible high-pitched squeal with the linings of the worn with excessively high squeal as a result of the lining wearing to the point that all is allow the metal indicator to rub against the rotor where the wheel turns because of the small friction area, the lack of the self-energizing servo effect, the disc brake assembly requires the use of the auxiliary power of the booster developing the hydraulic pressure for good braking. Floating calipers figure 1.9 are designed to move laterally. They are movements of the movement that allows the caliper to maintain center position with respect to the rotor. The design also permits the braking force to be applied equally to both sides of the rotor. The floating caliper is usually one piece of solid construction used with a single position to develop the brake force. The type of the caliper is operated with the pressurized hydraulic fluid. Like other hydraulic calipers, the fluid enters the piston cavity, begins with the force of the piston outward, happens with the brake pad meets with the motor. Additional press of force for the caliper assembly to move the opposite direction of the piston, thereby forcing the brake pad on the opposite side of the piston to engage the rotor. As the pressure builds up behind the piston, it forces the brake pad to tighten after the rotor develops an additional braking force. Disc brake assembly shows from the right side of the typical disc brake assembly. Braking disc, other auto caliper housing, bearing, counter pin, nut lock, ventilating lever, splash shield, inner caliper housing, brake shoe, brake lining pad. Piston being retracted shows the piston cylinder bore with the piston seal stretched and brake applied with the 5,000 inch caliper housing, piston seal stretched, brake release. Then you show the brake lining pad with the wear indicator, brake lining pad assembly, ventilated disc, and the rotor with the brake pedal, shoe, and the lining assembly, ventilated disc, rotor solid. Fixed calipers. Fixed calipers are mounted firmly on the spindle with a splash shield with the design with the caliper. You've made with the two pieces, 2, 3, or 4 positions. You've the position which made with the cast iron and aluminum plastic with the provide with the seal with the dust boots to fit snugly bores with the machine. Caliper to the piston with accomplishing with the center action of the fixed caliper as they move within the bores. If the lining was unevenly at one side of the caliper, the position would make an excessive clearance. Simply moving farther out of the bore, the brake is applied with the fluid pressure for the edge of the caliper on side of the rather than on the other side of the internal passage on the external tube of the connect with the opposite half of the caliper. As pressure is increased with the piston force of the brake pads against the rotor evenly with the pressure maintained with the equal amount of the pressure over the both sides of the rotor. Multi-piston design with a fixed caliper. You the multiple piston design is developed with the braking with the force of the fixed caliper may be designed with 2 or 3 or 4 pistons shown in figure 110. Dual piston design provided with the marginal safety overall piston floating caliper. The piston C with the caliper single piston caliper would enter use within a while, but the dual piston design would still have the working position and restore some of the breakability. The 3 and 4 piston design provides the use of the larger brake lining with the brake force to develop that may be spread over a large area of the brake pad. 1.7 mechanical brake for the wheels energized supply with the operator's foot while pushing down with the brake pedal to transfer the mechanical weapon. The mechanical wheels by the various means with the mechanical hookup that may be used with a single sense of the earliest motor vehicle with the mechanical operator of the brake system practically obsolete now. However, the mechanical hookups are still used with the portion of the brake system. 1.8 parking brake. The parking brake is designed to keep the vehicle stationary when it is parked. The parking brake can be used with the top of the vehicle with the emergency with the service brake if the fail with the release, and the parking brake is sometimes referred to as the emergency brake. The brake in the vehicle with the hydraulic system operates mechanically on the transmission to transfer the cage for the brake shoe with the rear wheels. The handbrake operates the rear wheels that usually linked with the small shoes. The operator with the hydraulic piston on top of the leverage of the use to apply the shoe for the arrangement with the hand lever to apply for the shoe either with the hydraulic brake pedal or mechanically normal operation brake action entirely when hydraulically forced with mechanical hookup the working with the connection system in the hydraulic system with the correction of the amount of the fluid lines of the brake properly set with the mechanical hookups and an active hydraulic system fail with the mechanical linkage acts as a safeguard. 1-9 floating caliper. Show the from the top right. Clockwise. Caliper boot seal, single piston, brake fluid, seal adapter, mounting bolt, steering knuckle, splash shield, brake disc hub assembly, inner bearing, outer bearing, spindles, wheel stud, shoe lining, and wheel. From the bottom left-hand corner, pads, rotor, dust boots, hydraulic seal, piston caliper, floating caliper, rotor. Fixed multi-pistons from fixed caliper rotor. Show the two piston caliber, a piston retaining pin, piston repelling dust cover the retaining pin, dust cover the piston sealing ring, two piston caliber. Show your caliper body with the bleed screw dust cap, and the three piston caliber, the sealing ring, the piston with the dust cover, the disc pad, the dust cover, the piston sealing ring, and then you have the caliper body with the pad retaining ring, dust cap, the retaining ring of the disc dampening sponge, the disc pad with the dust cover retaining ring, the dust cover the four piston caliper piston seal rings, caliper body with the pad retaining ring pin, blood screw, dust cap, pad pin retaining ring, pad retaining pin. Lesson 2: hydraulic brake systems. We're gonna cut the tape and we'll come back to it.